Good day, everybody. My name is Bolanle Otegbayo. I'm the product champion for pounded yam in RTB Foods. I'm presenting on key findings from RTB Foods on pounded yam in period 3. My outline is listed above. The countries where these activities are implemented are Nigeria, Cote d'Ivoire, and Côte d'Ivoire. And the scientists and the institutes that are involved are listed. I'm starting from the major highlights on pounded yam from IJFST paper. The title of our article is End User Preferences for Pounded Yam and Implications for Product Profile Development. The process in the article, we explain that pounded yam is a glutinous dough prepared by peeling, boiling, pounding, and kneading of boiled yam tubers. The key priority traits that were reported from our activity 3 in WP1, work package 1, which we actually based the article on, are color and textural quality. In Nigeria, the key priority traits are color and textural quality. However, there were differences based on WP3 work. There were differences in the ranking of these priority traits in both Southeast and Southwest. In Southeast, color is ranked first, and then textural quality attribute ranked next. In Southwest, textural quality is ranked first, and then color is ranked next. However, the textural quality attributes in both regions are the same thing, which are stretchability, moldability, stickiness, smoothness, moderate hardness, and softness. However, in both regions, stretchability, in fact, they are arranged in the order of preferences. And also in Côte d'Ivoire, textural quality was ranked first and then followed by color. Pounded yam was generally the preferred pounded yam quality characteristics. Preferred quality characteristics generally in pounded yam was stretchable dough, smooth, moldable, moderately soft, sweet taste, appealing smell with appealing color. We looked at it from gender perspectives, but we discovered that the attributes or the preferred quality characteristics are the same, almost the same in both the female and the male gender. However, the less preferred quality characteristics are dark colored dough, sticky dough, very hard or too soft dough, lumpy dough, that is, it has a lot of lumps, and pounded yam that does not stay long with a bitter state or an unappealing smell. From this, we were able to put down together the product profile of pounded yam from the raw material to the end product. From raw material, that is the yam tubers, the product profile shows that the farmers prefer healthy big tubers with low water content. The color of the skin was a brown, regular shape, and tubers with good storage ability. During processing, they prefer white flesh color or yellow or cream. However, the color must not change throughout the processing period. For instance, there should be no color change during peeling, during washing, during cooking, and during pounding. The boiled yam must have a short cooking time. The yam must be easy to peel, and then it must form a smooth glutinous dough easily. For the final product, that is what we have mentioned before, they prefer a white colored dough or cream or yellow, a dough that is stretchable, moldable, that is not sticky, that is smooth, and is moderately soft or hard with an appealing aroma or appealing taste. After we finish the work on activity 3, work package 1, we now followed it in period 3 with activity 4, which is participatory processing diagnosis for pounded yam in Nigeria. During activity 4, we worked with 10 processors, and we were able to identify the key processing steps in pounded yam as peeling, washing, cooking and pounding. And during this activity, we were able to see that pounding of the yam actually is in 3 stages: the mashing of the boiled yam, the second stage is dough formation, that is pounding for formation of the dough, and the third stage is kneading of the dough to a glutinous dough. The most important processing steps that can affect quality in pounded yam were identified as peeling and cooking. That is, it must not absorb too much water while cooking, and it must not be overcooked. And then the pounding stage, that is the 3 pounding stages. In activity 5, we were able to interview 330 consumers, and from the data that has been analyzed so far, the key priority traits that have been identified are stretchability, moldability, stickiness, smoothness, moderate hardness or softness, and color. Stretchability, moldability, stiffness, smoothness, moderate hardness, and softness are textural quality attributes. And then in development of new methods for phenotyping, we were able in period 3, we the scientists working on pounded yam in period 3, we were able to develop SOP for preparation and sensory evaluation of pounded yam. We were able to develop SOP for instrumental textural quality analysis of pounded yam, though this is still in progress, but it is remaining the validation. We were able to develop SOPs for color characterization, though this was done on boiled yam, but it is still very useful also, and we're reporting it also for pounded yam. And for biochemical analysis, we already developed SOP for starch and sugar analysis by hydrolysis, by acid hydrolysis. Now, in the process, during the period 3, we were able to identify the pounding yam machine that we'll use, and this pounding yam machine is able to tell us during the pounding, is able to identify pounded yam with good textural quality and also pounded yam with poor textural quality during the pounding process. And the pictorial representation is described above in the slide that is being presented. Also, during the SOP for preparation and sensory evaluation of pounded yam, this is the pictorial description of it, the flow chart, and we've already submitted it. It's already validated. From the SOP for preparation and sensory evaluation, we're able to have these ballots, which we'll all use as a template, as a sensory evaluation form for our trained panelists. This is presented in this table. SOP for instrumental textural quality of pounded yam. We were able to do this. We pounded the yam using the pounding yam machine, and then we use plastic molds in order to get a uniform dimension, since we know that this test is very much dimension sensitive. And then we use texture analyzer using pattern instrument, and then we use a flat-ended cylinder probe, 45 mm height and 75 mm in diameter. The texture analyzer is shown, the cylinder, the probe is also shown. From the results, there is correlation between, we correlated the sensory and instrumental parameters, and we're able to get correlation with quite some, with some of the parameters from both the sensory evaluation and the instrumental parameters. But the key one in both D alata and D rotundata are correlation between modability in sensory evaluation and cohesiveness in instrumental evaluation, and also between hardness in sensory evaluation and hardness in instrumental evaluation. And the coefficients, the correlation coefficients in both, the correlation coefficients for these parameters are 0.60, 0.63, 0.81, and 0.64 respectively in both D alata and D rotundata. The slide above, the slide being presented here, shows the TPA profile of D alata with good textural quality, TPA profile of D rotundata with good textural quality, and that's D alata with good textural quality and D rotundata with poor textural quality. I've mentioned the SOP that was described on color characterization and also how to characterize color and oxidation heterogeneous products by image analysis for pounded yam and for yam products generally. This was done in IRA and CIRAD. Now, development of tools and measurement methods, as we said, based on this, we're going to do the following analysis in period 4 on pounded yam in biochemical analysis. These are the proposed analysis and follow. Further to our work in period 3 is proof of concept to understand cooking or processing ability in pounded yam. In France, in CIRAD and IRA in France, they were able to use nails to identify pounded yam that is tagged either bad or good, using spectra and using the convolutional neural network with a binary cross entropy loss function. From this, preliminary results show that it is possible to produce the moldability of pounded yam, and also the springiness of pounded yam and the cohesiveness of pounded yam to an accuracy of 80, 95, and 100% respectively using the Nair spectra. Actually, we're going to work on development of our SOP to characterize stretchability also in pounded yam. In WP3 work, that is identification of elite clones from breeding programs, we're able to work on 2 biparental mapping populations consisting of 102 and 192 accessions of yam respectively, and also we're able to do flesh color characteristics, that is visual observation, using the CIRG and Brown indices, and then we're able to also look at the discoloration, and then chemical attributes using the NIRS, and also the textural attributes as reported under the proof of concept. In WP4, we were also able to work, though we did these ones on yam, but eventually we will do them on the pounded yam products from these yam products. We were able to use 2 approaches, QTL approach on 2 dialata biparental mapping populations that were mentioned in WP3 in the previous slide, and GWAS on diversity panel of 56 dialata varieties. We are also working on identification of candidate genes by comparative genomics. And still on this is the work on the QTL approach. And then in Guadeloupe, we'll have PhD student working on drivers of yam, that is dialata quality, and a postdoctoral position, there is a postdoctoral position on genomics too, by Anna Zonata. Generally, publication on pounded yam, from IRA, a publication has been published on predicting quality, texture, and chemical content of yam tubers using near-infrared spectroscopy. It has been accepted in Journal of Near-Infrared Spectroscopy. Also, there's another manuscript that is in progress, and this is on using convolutional neural network to predict tuber amylose content using NIRS. And I've mentioned the ones that we published before, and also identification of Q2 linked to physicochemical quality traits. This is also in progress. Now, perspectives for period 4 permit me to talk about it from different institutes. Bowen is going to complete report on activity 5, and then we're going to work on yam varieties collected from breeders, that is from WP4 diversity panels. We're going to work on 13 clones. We're going to conduct sensory evaluation, complete the SOP for instrumental textural evaluation, and also develop SOP on on how to measure stretchability in pounded yam, and also conduct biochemical analysis. And we're also going to work with RITA on developing high throughput method using NIRS to evaluate textural quality in pounded yam. We also have an MSc student working on quality attribute indicators in pounded yam. For NRCRI, they are going to work on the same thing that Bowen is working on in WP2. And on WP3, they will develop calibration for phenol and sugar binaries. They will join the African yam to carry out farmer participatory evaluation of pounded yam within 2 agroecological zones in southeast Nigeria and conduct G/E studies in different agroecological zones. We are very grateful to Bill and Melinda Gates Foundation, PMU, RTBfoods, Bowen University Management, NRCRI Management, CINRA Management, CIRAD INRA Management, IITA, and FSA. Thank you all for listening. Thank you all, everybody that contributed to this presentation. Thank you very much.